Hi, and welcome back to this lab power supply project. I'm doing a little bit more preliminary testing. Greetings, the Astro 30 here, yet again looking at this lab supply project. Now, before I pull this all apart and rebuild it correctly, well, not correctly, but better on a larger piece of breadboard, I've desoldered all the wires that were coming off of the tags on this transformer between the two, and I've separated them and just using jumper cables now. I have to rewire it anyway before I put it on the AEL 480 supply, which that video will be before this one. However, that's what I'm doing. And I've wired the two 12 volt windings in series with each other to give me 24 volt. It's actually 25 when all said and done. So across where our virtual negative is, which is the minus 5.1 volt rail there on pin 4, and the collector of this transistor, which is the power supply's input, I'm going to plug it in. And then I'm just going to measure what the voltage is. We're looking at 42 volt going across pins 7 and 4 of that op amp. The maximum supply is 44, so it is pushing it. Now I'll just set up my grounds and my output. There we go. So we've still got 0 volts. Not sure if there's any DC offset there. 0.7. The voltage is raised, so I'm going to have to lower that trim pot a bit, but that's okay. So we're still getting 0, and if I wind it all the way up, we're getting close to 37 volt out. Whew. Yeah, turn that right back down. She certainly can deliver, and it is pushing the envelope on that op amp. Now, someone in the comments on the last video on this did say that to make the output more stable, we really need a good voltage reference, and he's absolutely right, because all we're going to be doing is we're going on the unregulated main supply, and so the amplifier is going to follow that voltage, including any ripple that may be there. So I was looking around online for a solution for getting a voltage reference or better regulation, and I came across this circuit, as you do. Originally the voltage supply coming in here is 18 volt. We've got a minus 5 volt reference here, which is for the negative pin of the op amp. The original used a TL071, I'm using an NE5534. Why? It has a higher maximum voltage rating. Alright, so do you want me to go through how it works? Nah, I think we'll just pass and just build it. Let's go. No, I'm only joking. Ignore the op amp for now. It's not actually relevant at the moment. We're going to focus down here on our voltage pot. Now the ground of the voltage pot is referenced off the negative 5 volt rail. So then first goes through this 330 ohm current limiting resistor, for want of a better term. Then through this 1K trim pot. That's to adjust the 0 volt end. That is then driving our ground point on our volt pot, which then goes through another 270 ohm current limiting resistor, I suppose, all the way up to the adjust pin of the LM317T. Because these two pots are effectively referenced to the negative 5 volt rail, so too is the adjust pin. And what that means is we can actually achieve 0 volts on the output, because effectively this regulator IC is now seeing between the positive rail and a negative rail below a 0 point, or a bipolar supply. Now, moving on to what the op amp does. We've got our current adjust pot here, 100k linear, connected to our output line, and there's these 2.1 ohm 5 watt resistors, so for all intents and purposes 0.2 of an ohm. This is the current sense or current shunt resistor. This op amp down here is actually wired as a comparator, and this 100k resistor all the way around to here, back through this path, is its feedback path. And you'll notice that pin 3, the non-inverting input, is actually wired directly to the output, or the other side of this resistor network, and the pot is on this side of the resistor network. So it's effectively comparing the voltage across this resistor. Now this pot sets on pin 2 what the voltage across this resistor can reach. Okay, so say that this pot on pin 2 here is set to roughly 100 millivolts. Okay, once the voltage across on the other side of this network here exceeds 100 millivolts, well, via Ohm's law, that means we've got to half an amp. And what the comparator will do, or the op amp will do as a comparator, is it'll swing its output slightly negative below the negative voltage line down here, and it'll pass current through the limit LED, which is feeding off some of the output voltage from the regulator to light it up, and then shunt this adjust pin down. But if we had like 200 millivolts set here and 200 millivolts across there, that equates to 1 amp. Ohm's law. Isn't that neat? And of course we've got a TIP36C transistor here on the input as a series pass transistor for the output. Now, I forgot originally in the opening shot to connect pin 7 to the positive, but I've done that now. And we've got 10 nanofarad across pins 5 and 8 of the op amp just to keep this stable, as we found out in the previous video. It needs that there or else it will not be stable. So that's the basic circuit explained. It's not that complicated. I've explained it as best as I can and to the best of how I know it works and how I think it works. It was actually designed by someone from Silicon Chip at one point, Silicon Chip magazine, and his description was basically that this is driving the LM317T for current limiting with an op amp was just basically taken from their data sheet anyway. So if you want to build a current regulator and a voltage regulator, or a constant current and a constant voltage regulator, following the data sheet is how you do it, and that's what we end up with. So I can't find a data sheet that actually shows that topology, because Texas Instruments have changed some stuff in their application notes and they've cut out a lot of stuff for whatever reason. But I do remember seeing this circuit similarly a fair few years ago in their data sheet. So what we're going to do now is we're going to build the thing up on breadboard and verify it works. And for completeness, I'm going to show you the charge pump down here. So I'm going to build this circuit first and verify that we've got 5.16 volt on here. However, that -5 volt line would benefit from being regulated. So I'm going to use a 79LO5, which is a negative TO92 style package linear regulator here. In place of the Xeno diode, I'll get rid of the resistor, it won't be needed. Now, would this have worked directly with this anode of this diode here connected as our half-wave rectifier directly to the transformer? Would we have got a -5 volt here? No, we wouldn't, because if you think about it, where you're putting it from on the transformer is at the same potential after it's rectified by the full bridge rectifier, is at the same potential that you're trying to tap off of. So effectively the two cancel each other out. The way that this circuit is supposed to work is as the waveform from the transformer goes up and down and does its cycle and all that fun stuff, it's charging the plate of the capacitor here, and because of the reactance of the capacitor, it pumps it back through into the circuit. But it's only pumping in, well, I reckon it'd be pumping in both half cycles, and then this diode will just rectify the negative going half cycles. But don't forget, this diode is also connected to the negative rail, and the anode is facing the capacitor, so it's going to be pumping some of the positive half going cycles back into the negative rail. But for all intents and purposes, when I've measured it, it doesn't seem to make that much of a difference to it. And so, no, it will not work without this capacitor here. So I'm going to build it up now and test it. Penis. Okay, so all that circuitry's got to go, because it was a nice idea, but yeah. Okay, so this is all going to magically disappear now. And like magic, it's gone. Now you'll notice I've got a larger breadboard here. I just went out and spent $82 at JCar this morning, so they really should get on to sponsoring this channel. I mean, they're a multi-million-dollar a year profit organisation. I'm sure they can spare a couple of $100 to give to me. Anyway, what I'm starting with is with this circuit, because I want to use a negative 5 volt regulator here instead of the Zener diode, but I want to know what voltage DC is coming out at this node between this point and the common rail. Because the last thing I want to do is blow the arsehole off of a little 79L05 IC, because I think their maximum input voltage is 16 volt. So I've got the multimeter hooked up. The positive probe is hooked across that node and the negative's going to common. So I'll just hook the supply up. Right, 20 volts. I'm currently coming off of the 15 volt winding of the transformer to test with first. So that voltage I cannot put into the regulator. I'm going to have to use a Zener diode to drop it down. Alright, the 12 volt Zener is now in. There we go, we got 12 volts. I know it's now safe to put it through a 5 volt regulator. The reason I'm going to use a 5 volt regulator is because I want a well regulated, or well enough regulated supply for the negative reference voltage for both the op amp and the LM317T, so it's not going up and down in voltage, if you know what I mean. Okay, the 79L05 is in circuit now. 1 is the input, 2 is the ground, and 3 is the output, in that order from left to right. I can't use this regulator because it's a 78L05, not a 79L05. Jesus Christ. So that's pretty much well useless. I did check it. Yep. Unfortunately it's a 78L05. Okay, well I'm going back to my 5.1 volt Zener diode arrangement then. I've lost some footage because I left the camera recording accidentally for half an hour and didn't realise I didn't record the bit before it. Anyway, I did test the Zener circuit. It was putting out 5.1 volt, 5.2 minus, and I've got the 1000 microfarad capacitor across it. Now I've got the circuit built. I've got the TIP36C just hanging up here in the breeze because I want to make sure that is the device passing the current, not the 317T. It's a bit of a rat's nest, but I hope it works. Well, I think it will work if I've wired it correctly. It should work. Anyway, I've got the voltage pot set to half and I've got the current pot set to half because I don't know if I've got the clockwise and counterclockwise positions wired correctly. I'm just following the schematic. So what I need to do is hook up my multimeter to the output so I can measure things. The output's over here on the other end of this resistor, and a suitable negative from somewhere down there will do. Alright, I'm kind of nervous at this point. Hopefully nothing goes off with a bang. I'm still on 15 volt secondary at the moment. That is still connected to that circuit, so here we go. Oh, got an output. 14 volt. I don't see any magic smoke. It's just my voltage pot. Yeah, the pot's wired backwards. Okay, well that's good to know. And we're still getting, oh, we're getting less than the reference voltage. I reckon it's because the capacitor that's across the output of that pot is discharging. So I'm going to have to wait for things to discharge. It's not getting hot. I'm going to play with the current pot and see what that does. I think that's wired correctly. The LED is not illuminated though. Okay. So what happens when we rotate this zero adjust pot? That's the next thing I want to know. That's going up. It is going down. That was my soldering iron. It's coming back up again, so yeah, it's not completely zero. Okay, so I'm going to set that to about 3 volt, roughly thereabouts. I'm going to have to reverse the connections on the pot eventually, but what I want to test now is A, this thing can pass current, and B, that current limiting works. Because as far as I know, adjusting this pot does not affect the voltage. No, it doesn't. So that's good, it's not going to interfere with anything. So I'll connect this to God knows where. Any place where there is a negative connection will do. And touch the output. I want to make it stay there, so I'll clip it to a clip lead. That'll be easier, wouldn't it? So it is still dropping down by at least half a volt. Current limiting doesn't seem to... Oh, there we go, that pot's wired backwards as well. The LED did illuminate. My test light is glowing. And if I have a load on it, you will get exactly 0 volts. So I want to make sure how far out we are. 1.2 millivolt. Can that be trimmed out any further? I don't really think so. So I'll take it up to 7 volts. That transistor's starting to warm up. The regulator is not. Okay, so before I continue testing, I'm going to bolt, well not bolt, but clip it to an aluminum piece of stock, is what I was trying to say, just as a heat sink. So I need to, just doesn't matter how I do it. So I now know that the transistor is passing the current. I don't think this is set right, so I don't want to damage the transistor. Oops, that's too loose. Let's see. Let's try that again. Okay, it's clipped. Right, now, so both pots are wired backwards. I've got to be careful of this pot now because that is positive volt. Actually no, that's the output voltage on there, and if I short anything up against it I could kill it. Right, so we got 7 odd volt coming out. I'll disconnect the load. It drops down a bit, but not significant enough to worry about it. So with current limiting, yeah, when the LED's lit up we can see what happens. We're in current limit mode now. That IC is not getting even remotely warm. We've actually dropped down to 1.4 odd volt, and if I play with the pot for the voltage, that does not come back up. And I believe it's 60 mA when the light's lit up. So now what I want to do is adjust the correct pot until current limiting goes off. There we go, the load's lit up. I want to find out what voltage is coming out of the op amp, on pin 6 basically, before the LED when it's in current limiting mode. The current limiting is not in limit. I've got the positive of my multimeter across the, is that the anode? Yeah, the anode, no, the cathode of the LED, which is coming off pin 6. So I'll adjust my pot till it current limits. And with respect to the negative rail, it's putting out minus 2.2 volt. What that's with respect to the virtual ground, I'll just move my negative probe, 1.5 volt DC. So I'll hook that up to there if I can. And I'll take current limiting off. It goes up almost to the full supply voltage. Okay, so that's how the current limiting works. Okay, so I've got a 1 ohm 10 watt resistor. I'll just back that voltage up again. Or in current limit I can't. I'm just going to rotate the current limit pot till the light goes out. Alright. So at 1 volt, I know with a 1 ohm resistor there should be 1 amp going through that. Now that LM317T is starting to warm up. So I've got roughly a third of rotation there. I doubt this is going to go up to the full 5 amps. So what I'll do is I will wind the current limit up again. I'll slowly increase the voltage to 2 volt, which will be 2 amps. So we're at 2 volt. Current limit hasn't come on yet. Back that off until it does. Got the current limiting there. So yeah, it's a very finicky control. It's not really accurate. So I'll keep winding the voltage up to 3 volts, which is 3 amps. And we're still not in current limit. We are now. So, but that's still at a third of the rotation of the pot. So yeah, that's, yeah, it is what it is. So the 317 is starting to warm up, so it is passing some current as well, so we've got to be careful of that. So I'll wind that right back off and disconnect the load. And oh, that resistor is quite warm. So yes, it works. I think I'm going to leave my 5.1 Zener setup arrangement here alone. It's doing what it's doing okay. Now the thing is, I'm only running on roughly 18 volts coming in. I want to see what happens when I connect it up to the full 24 volt. Okay, it's hooked up to 24 volts now. I know that the rough input to output differential of that 317T is about 40 volts, so it should handle it. Okay, there's no load connected currently, just the multimeter, so I'll plug it in. Hopefully nothing goes off with a tremendous bang, or else I'm gonna be scared to shit. So I plug it in. Nothing happens. But I am closer to 0 volt now. That's because it's not doing anything. Take 2, I had the 2 windings of the transformer wired out of phase with each other, so it's going to cancel out the voltage. Let's try that again. Oh, got power, got an output voltage, nothing went off with a bang. So now the output's well closer to 5 volt. Alright. Moved around. Right, now that pot makes more sense. Okay, and this pot should make more sense. So as soon as I connect a load, that should go straight into current limit. Well, when I give it some voltage. No, it doesn't. I wonder why that's not current limiting. Okay, I've done something wrong. Well, I believe I've killed another any 5534, and the spare one I had, I hooked it in the circuit incorrectly, a couple of pins out, or one pin out. Focus, you bastard. I blew the shit out of it. It actually smoked, one of the legs actually came off. So I haven't got another any 5534 to actually confirm that the IC is indeed rooted. Don't know what happened. I think this frequency compensation capacitor was shorting against this other 100 nanofarad, which is going to the positive, so it was putting voltage where it shouldn't be. If it was, I was putting it on pin 8. That's, yeah, okay, I don't know. I think I've killed it. I don't have another one to test it. But as soon as I move the pot around, this doesn't do anything anymore. So it's not current limiting. Don't believe any wires have fallen off. I've measured the voltage across the op amp. It's only 36 volts, so it was within the where it should have been. But yeah, no, I've killed it. So I need a quicker way of testing op amps to see if they're still working. But I don't have a way to do that. So with all this exposed wiring and resistors close to each other, it is very easy for it to short circuit stuff. So I'm going to have to buy another NE5534 to continue testing. And I can still smell the magic smoke that came out that other op amp that caught on fire. Oh, it's actually charred the board down here. See, all the magic smoke came out of it because I actually had it one pin over to the right. So I was putting the negative up pin 3 and the positive down pin 8, I believe. Yeah, it just completely killed it. I saw smoke coming up and it was popping away. It's like, oh shit. So I've destroyed that op amp by accident, and this one I don't know what happened to it, but it doesn't appear to be functioning anymore. If I turn the pot, the light doesn't come on. So it's not actually doing anything as far as I know. When I was measuring from the positive rail to my virtual negative output, I was actually getting 50 volt across it. So there was 50 volt across that IC, and that's what the meter said. So I've put it back down to 15 volt. So I'm going to probably only go for a maximum of an 18 volt transformer, otherwise I'm just going to blow shit up. So I've fried that IC, so I'm going to need to get a new IC because the current limiting doesn't work anymore, which is fucking annoying. But that IC will need to go into a heatsink because it is getting hot. But it is quite capable of going over 12 volt. We're up to 15 volt max at the moment now. So I suppose for a little lab power supply, it's not really that critical of what voltage I have. But yeah, I just can't stop blowing up ICs. It's getting kind of annoying now. So I'm just going to back that 0 back off again. So, because it's at different voltage potential now. So a maximum of 18 volt transformer, I reckon. That's about as close as I'm going to get that. Load doesn't change. And we're getting voltage. I've got the test light hooked up across it. Yeah, it's going up to 15 volt. So I'll need to get a new NE5532 for Christ's sake. This is just, I mean 5534. Oh, this is just a cluster. Fuck, this is. Okay, well the charge pump circuit idea is out because it is pumping voltage into the positive rail. At the 20 volt rail with the -5 volt rail here, I was getting the positive rail up to 30 volt. That's unacceptable. And I've also come to the conclusion that I may need to run on a dual rail supply. that kind of defeats the purpose of the single mode operation, but it is what it is. So now I've got it hooked up as bipolar, so there's 20 volt DC coming out the positive lead and minus 20 volt DC coming out the negative lead, 0 in the middle, so 40 volt across the two, off the two 15 volt taps. And I'm just going into, on the negative voltage side, a simple shunt Xenodiode arrangement. So a current limiting resistor of about 680, or that's probably close to 820 now, and the Xenodiode 5.1, and it's maintaining 5.1, 5.3. I still haven't got any 5534 yet. I'll just hook up across the negative supply. And we're maintaining minus 5.27. Now the problem was, as the circuit was operating, that voltage was jumping around all over the place. It kept on going down to about 3.5 volt, which kept getting my zero adjustment out, and it was just annoying the piss out of me. So I elected to use a dual supply. Now that means I'm going to have to find possibly an 18018 transformer that's capable of at least 4.5 amps on its secondary, wide in series, not parallel. So that's getting quite expensive, but it is working. I'm down to 0 thereabouts, and it's maintaining 0, so I can go up to a maximum on this supply of 20 volts. And if I measure the voltage across the positive rail and the negative rail, which is the 0 volt of this power supply, it should still be at 20 odd volt. Where's a good place to connect it? There's a good place to connect it. So we've got 21.65 at the end of the day there. So, and we're getting around about 20 out, so we're only losing 1.5. Okay, I'm at 10 volt. Problem is when I connect my load, it still does drop down a bit, but yeah, I guess that's just how things work. Okay, so I'm going to need to get a new NE5534 because I've blown that up, and go back to testing. Anyway, I'm going to leave this video here. I think it's gone on long enough, so I'll sort out all the problems with this circuit in the next video. Hopefully, if you never see a part 3, well, you'll know why. Anyway, I'm the Astro30. If you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and become a Patreon member for as little as $1 a month. Links are in the description down below, guys. Anyway, this is the Astro30 saying, see ya, have a great day. Why does everything turn into a saga with me? Because you're a dumbass.